Hello everyone, I just want to go through the next step of our kind of review day of solving systems of linear equations, and we're just going to be working with two variables, two equations with two variables, and I just want to go over each of these three examples. So the main thing that I want to touch base with you on and want to remind you of, that in order to solve this system of linear equations, and by the way we're going to do it by elimination, is the need for opposites. Okay, so I'm going to put this on the top here. You need what are called opposites. And examples of opposites would be like 2x and negative 2x, 3y and negative 3y. Because in order to do this, in order to do elimination, you have to have opposites so you can eliminate a variable. So right over here I'm going to write just kind of the general process. The first step in this general process is to get opposites. Sometimes they're given to you, sometimes they're not. The second step is to add your equations, so I'll just put add. The third step is to solve. Okay, so we're doing a little algebra. Fourth step, substitution. And fifth step is to check. Okay, no one of these steps are difficult at all, it's just you got to kind of remember the procedure. Okay, so our first step is opposites. So we need some opposites here. So if we look at this first equation, 3x plus y equals 7, negative 2x minus y equals 9. And so what we want to look for is our opposites. So the question you have to ask yourself is, are there opposites in this equation already? And the answer to that is yes, because we have positive y, or positive 1y, and negative 1y. So step 1 is already done for us. All right, step 2 then. We can add everything straight down. So I'm going to take 3x and negative 2x and add it, and I just get x. Y and negative y, add them, and it becomes 0. That's what we want to have happen. We want one of our variables to be gone, and then 7 plus 9 is 16. Okay, so that's what I mean by add. You add everything straight down after you have opposites. The third thing we want to do is solve. Well, if we had like 2x equals 16, we'd have to divide by 2 to solve, but this one's already done. This one's already solved for us. So, halfway home. So that's the third step. We solved. We got what variable was left and we solved for it. The next step is we want to substitute. So when you go to substitute, what you need to do is you need to pick one of these equations and substitute in this variable, whatever we solved for, and then solve for the other variable. Okay? So I'm going to pick this top equation. You can pick the bottom one if you want. The reason I picked the top is there's no negatives in it. So what I have to do is take this equation, 3x plus y equals 7, and I have to substitute 16 in there and then solve for y. So what are we going to get? 3 times 16 plus y equals 7. 3 times 16, just doing my algebra, is 48 plus y equals 7. Take away 48 from both sides, and we have y equals negative 41. Okay? So there's the fourth step, substitute. Now the fifth step, we have to check it. So what do I mean by check? Basically what I have to do is I have to verify that 16 and negative 4 are correct answers. Well, the only way to do that is to pick the other equation that we didn't use, in this case the negative 2x minus y equals 9. And I have to take this 16 and negative 41, plug them into here to see if I get an answer of 9. So let's check that out. So negative 2 times 16 minus a negative 41, be careful with your negatives, okay, equals 9. If I simplify that, and you can even put parentheses around this, by the way, if you're comfortable with that. Alright, so now my next step is to go negative 2 times 16, which is negative 32. Negative 41 is plus 41. And equals 9. Negative 32 plus 41 is 9. 9 equals 9. Check. Okay. Final step is to take this and write it in coordinate form. We know it's correct because I used the 3x plus y equals 7 to get this answer, and then I use these two in my other equation to verify that it works, and it does indeed work. So final answer, 16, negative 41. Okay, next example. 4x plus 3y equals 2. 6x minus 9y equals 3. First question, once again, do we have opposites? And hopefully you can look at that and say no. Okay, so what do I have to do to get opposites? Well, if you notice here, I've got a negative 9y and a positive 3y. Those two are the 9 and 3 are multiples of each other. So what you can do is you can take this top equation and you can multiply everything by 3. That's legal math. And watch what happens to my top equation now. I go 4x times 3 and I get 12x. I can go 3 times 3 and I get 9y. And I can go 3 times 2 and I get, I get 6. These two equations are called equivalent equations. It's just this bottom one is multiplied by 3. And as long as I multiply everything by 3, that's legal. Now what happens when I rewrite the bottom one? I now have opposites, 9y and negative 9y. So that's a good thing. Alright, so what do we do? So first step is opposites. Next step is to add. So I go 12x plus 6x is 18x. My y's disappear. And I get 9. Divide by 18. And I get x equals 1/2. Okay? Alright, so that's my first step. I should say my second step. So I got opposites. I then added straight down. I solved. And I got, so actually first 3 steps, and I got x equals 1/2. Now what do we have to do? We have to take 1/2 and we have to plug it into either one of these equations. I'm going to pick the top one again. So 4, instead of x, I'm going to plug in 1/2 plus 3y, and that equals 2. 4 times 1/2 is 2, so I get 2 plus 3y equals 2, and now I do my algebra. Minus 2 minus 2, 3y equals 0, divide by 3, and I get y equals 0. Okay? I need to verify that. I need to do my check, so I have to go back up to this equation right here. Plug in 1/2 for x, plug in 0 for y. So I'm going to go 6 times 1/2 plus... Sorry, that's the dog hitting the door, if you heard that, trying to get in, so hopefully it won't be too much of a distraction. Let me try that again. 6 times 1/2 plus negative 9 or minus 9 times 0 equals 3. 6 times 1/2 is 3, so this becomes 3, this becomes 0. 3 equals 3, we're good. Rewrite your answer as a coordinate, and how's that? There's our final answer right there. Alright, third one. Third one, you got lots of options here, but I'm gonna take a little bit more difficult option. What I want to do is I want to eliminate x's here. So, and I just want to show you that you can eliminate the x's also. So the top one has 2x, the bottom one has 1x. I want to get opposites, so the opposite of 2 is going to be negative 2. So that means I got to multiply everything by negative 2. So I'm going to rewrite the top equation first. Equals 3. And then I multiply each of these by negative 2. I get negative 2x. Negative 4y times negative 2 is positive 8y. And negative 1 times negative 2 is 2. And so we have that right there. And now we add straight down. So let's see here. These cancel. I get 10y. 10y equals 5. And here we divide by 10. We get y once again equals 1/2. Pick one of the equations. I will pick the bottom one this time. Like I said, it doesn't matter. X minus 4, I'm going to substitute in for y this time, times 1/2 equals negative 1. Do my algebra. X minus 2, half of 4 is 2, equals negative 1. We add 2 to both sides, and I get x equals 1. I need to verify that, so I'm going to verify that in the top equation. So 2 times x, or 2 times 1, plus 2 times y, which is 1/2. And that should come out to be 3. So this is 2, this is 1. And I think we can see that that's going to work. So final answer, make sure you put your x first, 1, comma, 1/2. Voila! Alright, from here now, what I want you to do is I want you to do these problems right here. So do exactly what I did. If you have opposites, take care of it and go through that 5-step procedure. It does say up in the instructions to use the graphs on the next page. It's just change that to below. I was able to get them all on the same page. So then once you have these equations and their solutions, see where they match up down here. So just list